Hello, everyone, and welcome to day 10 of the Advent of Cyber Challenge. I know at this point I am doing the challenges out of order. I have been under the weather. I have, at the beginning of the week, I received the third booster shot and have been out of sorts and am just now starting to feel like myself again. So instead of trying to catch up, I'm just going to work on the day's challenges and then go back and work on the challenges that I missed and just loop those in the current challenges. So some days you might get two challenges with the current challenge and then a challenge that I missed. So that's why you have not had challenges for me. Now, going into today's challenge, day 10, now we're in networking, and offense is the best defense. So now, McSkitty, which is us, now we have to discover how an attacker manages to penetrate a network and cause damage to the best festival company's infrastructure. So we have to decide by doing a security assessment of the system to discover how Grinch Enterprises managed to cause the damage. So we did the security assessment of the system and discovered how Grinch System managed to do the damage and the service they exploited. So we're going to do this by using Nmap or Network Mapper. But before we use Nmap, we need to learn some terms such as IP address, protocol, server, and port number. So I'm going to explain these a bit briefly and then we're going to jump into the challenge. But first, let me start the machine so we can get that ready. So an IP address is a host. Every computer has an IP address and that connects to a network. So there's the IP address. Currently, there's an IP version 4, and that's in broken in numbers and four buckets. So, for instance, 192.168.0.10, and that's the current version. But we're moving to IP version 6 because with IP version 4, we're running out of space. So as it says, IP version 4 is made up of 4 decimal numbers, each number ranging from 0 to 255. And the three numbers and the list above are private, meaning they can only be accessible by a private network that they belong to, and the example and the list that's provided above. And then the last IP address, 111, is a public IP address that can be accessed by the whole internet, and it belongs to Cloudflare. And then some IP addresses serve a special purpose. So, for example, you have probably seen the IP address online 127.0.0.1, and that is often referred to as the loopback address or localhost. And that is by default any packet or traffic destination to this address won't leave the host. So, for instance, if you want to make sure that your internet is working, you can, for instance, use this special IP address 127.0.0.1. And if, for instance, you're seeing traffic going to this IP address, then you know, okay, my internet is working. Now, on Windows, you can find your IP address by running the command ipconfig. On Linux, you can use if config, and that's how you can use that. And so an example here is they're using IP address show. And then if we look down, we'll see here that okay, so the IP so you okay, you can find your IP address by executing IP address show. So here it's showing that the IP address is 192.168.0.202, and that's the wireless adapter. And if you want to know more, you can go to the Network's Fundamentals module. So, with protocols and servers. So, again, with us, we're most likely the client. And when we are doing things on our website, we are talking with a server, but we need a way to talk to the server and have the server understand what we're saying. And we need to understand when the server sends us something, we need to understand what the server is saying to us. So we need a common language from us to the server and the server back to us. And so that common language is the protocol. An example of this is using the customer and the barista, and they're talking to each other, right? So the protocol in this instance is talking English. So the customer is like, hello. The barista is like, hello. Customer is like, I want one espresso, please. The barista's like, that will be $3. Customers like, here you are, $3. Barista's like, thank you, your espresso is ready. And customers like, thank you. Now, there are a few protocols. So, for instance, we already spoke about one protocol, that Hypertext Transfer Protocol, or HTTP, and that's what we use to view web pages. And we're using HTTP now to view this web page. The Domain Name System, or DNS protocol, for resolving host names to IP addresses, and we're actually using this protocol as well, because instead of having tryhackme.com, if we did not have DNS, this would actually be a IP address instead of tryhackme.com. Then there's the Post Office Protocol version 3 for delivering email, Simple Mail Transfer Protocol for sending mail, Telnet for remote login, and Secure Shell for secure remote login. So, if you want to learn more about these protocols, we suggest you join the Protocols and Servers room at this link here. Finally, on a host, there are multiple programs or processes that can be accessed on the network at the same time, right? So since you have these multiple processes that can be acted upon simultaneously, there needs to be a way for the network to tell where to send the packet to. And so we introduce port numbers. So let's just say we have the Try Hack Me company in London. And let's imagine there are 100 offices for 100 content engineers. The company address is like a public IP address. With the company address, the mailman, analogy for a router, knows how to reach the company and deliver mail packages. The port number is like the office number within the company. The mailman can deliver to the company address and hand it to the receptionist. However, a TryHackMe employee will deliver the package to the internal office. When multiple processes are using the network or internet simultaneously, each process can be recognized by the port number it is using. In public servers, default port numbers are used by different protocols so that clients don't need to guess. The table below shows some of the common protocols and the port numbers they use by default. So for example, HTTP by default uses port 80, HTTPS by default uses port 443, POP version 3 by default uses port 110, SMTP by default uses port 25, SSH by default uses 22, Telnet by default uses port 23. So, and we have an example. Now, imagine there's an IP packet coming to the server with the IP address 10.10.13.13, and it will be delivered to the running process based on the destination port number. So, for packets of type TCP with port number 22, the destination process is the SSH server. Why? Because the port number 22 belongs to SSH. For packets of the type TCP with the port number 80, the destination process is the HTTP server because port number 80 belongs to the protocol HTTP. And for packets of the type UDP or TCP with the port number 53, the destination process is DNS. And TCP and UDP is outside the scope of this challenge. These are the two protocols that are common on for networking for the internet today. But again, that's outside of the challenge, outside the scope of this challenge, but it was mentioned for the illustration of the example. Now, we did the primer because, again, we're doing the security assessment and we're going to use the tool Nmap or Network Mapper, right? So McSkitty, which is us, we are going to do a security assessment because we need to figure out how Grinch got into the best company and, did their nefarious things, right? So now we look and it's like, okay, McSkitty can run a very basic network port scan using the command nmap-st and our IP address 10.10.10.123, yours will be different, or nmap-s capital S and case matters 10.10.10.123. By default, Nmap checks the 1000 most common TCP ports. That is very important, right? Keep that in mind. Tcp Connect Scan. To run this type of scan, the -S capital T option is required. Nmap will attempt to complete the three-way handshake in order to establish a connection with each port scanned, right? So with TCP, there is a three-way handshake. And so if, for instance, if any of if the three-way handshake is not established, then that port would not show up in the scan. TCP send scan, you can select this scan with the capital S option, and Nmap will not make a complete connection if the port is open. Technically speaking, Nmap does not complete a TCP three-way handshake. To better understand the difference between these two options, we can use the analogy of knocking on a door. The TCP Connect Scan is like knocking on a door, waiting for someone to open it, greeting each other, then excusing yourself to leave. The TCP Send Scan resembles knocking, and once someone answers, you pretend that it was not you that knocked and walk away innocently. The latter will make it more difficult for the other party to remember you. Now, Help Miss Kitty and run this scan. How many ports are open between 1 and 100? So I have Kali open, and let's see. I'm going to copy this. I'm going to. Okay. There are 2 ports open, SSH and HTTP. 2. Okay. I'm in a virtual machine, so let's try this again. Okay. What is the smallest port number that is open? 22 SSH. What is the service related to the highest port number you found in the first question? HTTP. The highest port is 80 and the service is HTTP. Now we're going to run the second scan. Now remember, this scan did the 3-way handshake. So that was the analogy of knocking on the door, waiting for someone to answer, greeting them, and then excusing yourself. Now this scan is knocking on the door, and then when someone comes to the door, we're going to walk away and say, oh no, that wasn't me, right? This doesn't complete the 3-way handshake. Okay, and let me do that. Because it was saying I needed root privileges. And it's saying the same. Did we get the same results? Yes. If you want Nmap to detect the version info of the services installed, you can use nmap-sv. What is the version number of the web server? So we're going to run another to get the version number. So let's do that. So in this instance, running the Nmap scan with the 3-way handshake and without the three-way handshake returned the same results. But that's not always the case. So don't always believe that's the case. In this instance, it was, but that's not always true. And the version is Apache HTTPD 2.4.49. I want to copy that, and I'm going to paste. Now, by checking the vulnerabilities related to the installed web server, you learn that there is a critical vulnerability that allows path traversal and remote code execution. Now you can tell McSkitty that Grinch Enterprises used this vulnerability. What is the CVE number of the vulnerability that was solved in version 2.4.51? So, critical path traversal and remote code execution in Apache HTTP Server 2.4.49 and 2.4.50, fixed in Apache 2.4.51. So let's try CVE 2021 41173. Let's try this one. Okay. Let's see. Let's see. Uh-oh. Let's try the CVE 2021 42013. Okay. So, I so what I didn't do, so it was incomplete fix, and that was my error. So it was this was the CVE, because if you click it, it actually takes you to MITRE, which handles CVEs, common vulnerability exposures, and clicking the link actually takes you to the CVE in question. Now, you are putting the pieces together and have a good idea of how your web server was exploited. McSkitty is suspicious that the attacker might have installed a backdoor. She asks you to check if there is some service listening on an uncommon port, i.e. outside the 1,000 common ports that Nmap scans by default. She explains that adding -P1 to 65535 or -P- will scan all 65,535. That's how many TCP ports there are, instead of only scanning the 1,000 most common ports. What is the port number that appeared in the results now? So let's do it. And I'm going to do... I'm doing the one where the connection is not made. And I added it to do all 65,535 ports, which is a good trick because, for instance, while we're waiting for this to happen, because if you're doing a scan and you're looking and it's like, this looks like it's not enough ports, if you start scanning for all ports, right, not just the common 1,000, what will happen is system administrator, network administrator, what they would do is they might try to put ports on uncommon, might try to put services on uncommon ports to throw you off. And because then they're like, because if you assume that, for instance, HTTP is always going to be on 80, they might put HTTP on 8,000, right? And if you're looking for it on 80, you'll never find it. So it's always good to not just search on just the common 1,000 ports. And so we're waiting for this. It's going to take a while because we're looking for all 65,535 ports. You know what? I'm going to stop this scan and I am actually going to do it on the version, because I'm looking at the next question and it's like, what is the name of the program listening on the newly discovered port? So we might need the version. So let me just execute it there. Okay. And I'm going to show you a trick that's not shown in this challenge, because as you see with the 2, we're really not seeing any output. But if you add the -VV, that's verbose. And so what that happens is it will display output. So it will show us what is happening. So we see 80 and 22, which we found before. And so now we can see what Nmap is doing as opposed to just a blank screen. So as you can see, this is going to take a while because it's 33 minutes. Okay, so I have cut a good portion of the video. I have cut a good portion of the verbose printing because as you can see, it was 30 minutes and I just didn't want 30 minutes of you all to see the Nmap completing. So now our Nmap scan is complete. So let's go back to the questions. Okay, now we have executed the Nmap scan for all 65,535 ports, TCP ports, and not the 1,000 most common that is normally done. So what port did we find? Going back to our results, we found port 20,212. So 20,212. That is correct. What is the name of the programming listening on the newly discovered port? It is, and that's why because originally I was just going to do the TCP without this scan without the TCP handshake, but then I said no, let me do the scan with the services because I knew I would need it for this question. And going back, the program is tailnet-d. Let's see if that is the answer. So I'm gonna copy that and let me see, let me paste, and yep, that is the answer. And it says, if you would like to learn more about the topics covered in today's tasks, we recommend checking out the network security module. And I'm just going to click that. And I believe you need to have a subscription. Well, the first 3 rooms are free. And then, yes, the remaining rooms are, you need a subscription. That's what the VIP stands for. You need subscriptions to do that. So that's completed. So we learned quite a bit in this challenge. We looked at Nmap, Network Mapper. We learned about protocols, IP addresses. I talked a little bit about IPv version 4, a little bit of vaguely about IPv version 6. Ports, TCP, UDP, even though that was outside the scope of this challenge. And I can't wait to see you in the next challenge. Oh, as I said, I am running behind because I had my booster done Monday and I was under the weather. So the challenges that I am behind, I am going to loop those into the current challenges. So for some days, you're going to see 2 challenges from me. So a current challenge and a challenge that I missed. So don't be alarmed if you see 2 challenges from me. So I can't wait to see you in the next video with the new challenge as McSkitty for the cyber Avid of Cyber for Try Hack Me. Have a good day. Bye.